Hi guys, this is a reshoot of the 2.3 review questions. Number 7 was fine, but number 8, someone's asking me a question about how to know that they factored correctly. And as I was thinking about that, I realized that I actually made a mistake the first time I went about this. So I'm going to explain what that mistake is, and we're actually going to have an extra credit question revolving that kind of mistake that I made. So let me explain number 7 again, since I'm reshooting this first though. So 7, we're using synthetic division and the remainder theorem to find the value of the function at a given x value. And the remainder theorem just says if you run your division, the remainder is equivalent to the value at that position, at that point. So that's for when you have when you're checking these numerical values, right? So what I mean by that is if you look at g of x and I run my synthetic division with 1 for x equal to 1, then it would look like this. The coefficients are 2, -3. There's no x term, so 0 there, and then 1, right? The synthetic division algorithm brings the 2 down. 2 times 1 is 2, plus -3 is -1. Times -1 is -1, plus 0 is -1. Times 1 is -1, and plus 1 is 0. So this here is the remainder. It just so happens that the remainder is 0. But what that means is that g of 1 is equal to 0, the remainder over here. Okay, we're going to do the same thing with -1/2. So -1/2, again, my coefficients of the polynomial, bring the 2 down. 2 times -1/2 is -1, plus -3 is -4. Times -1/2 is +2, plus 0 is 2, times -1/2 is -1, plus 1 is 0 again. So this one just so happens to be 0 again. And what that means is g of -1/2 is equal to 0. Now, if this number was something else, it would mean g of -1/2 was whatever the remainder was. Whatever number that pops out here, that's the value if I was to evaluate it. Okay, so we answered question 7. Both cases give us 0. Okay, now the question I really wanted to talk to you about is question number 8, and in particular step C. So once we get to step C, I'll explain what the issue was. But let's start by answering the beginning of the question. So I've got this polynomial, right? This polynomial I'm looking at. And then I want to find the possible rational roots using the rational zero test. So rational zero test says, okay, look at your last term and then look at your first term. Whatever, any rational number that's a root, the numerator should divide this. The p should divide that, right? And the q should divide this first number. So that means, starting with this last number, possible rational roots are going to be plus or minus 1 and plus or minus 2. Those are things that divide 2, right? And then for the denominators, you're going to have things that divide 6. So just now I did 1 implicitly, right? I mean, like 2 over 1 is just 2 and 1 over 1 is just 1. So next number would be 2. So I could have 1 over plus or minus 1 over 2, or plus or minus 2 over 2. But of course, plus or minus 2 over 2 is just 1 again, so I don't need to include that one. And then next, this 6 could be divided by 3, so I get plus or minus 1 over 3, or plus or minus 2 over 3. And then plus or minus 1 over 6, or plus or minus 2 over 6, but 2 over 6 is actually just 1/3, and I already had 1/3, so I don't need to include that one. Okay, so here are my possible rational roots. Okay, that's part A. Now part B, use synthetic division and the quadratic equation to find all zeros. All right, let's do that. So we're gonna pick from this list and try to find our rational zeros, yeah. And looking at it, let me just do a quick check. If I was to plug in 1 here, 1 here, that would be way too big to overcome this one negative number. So I know 1's not gonna work, but let's try -1, see if that will work. Oh, yeah. 1, -2. So this is just running my synthetic division, checking -1. 6 comes down, -6, that's 7, times -1 is -7, plus 1 -6, times -1 is +6, which gives me 4, so this did not work. Yeah, -1 is not a root. Okay, what about 2? Let's check 2. Let me think, actually. Actually, no, I'm going to skip 2 because look, same thing, right? Looking at these values, if I plug in 2 here, all three of these are going to be positive. There's no way it's going to balance out to 0 with that single -2. So I'm going to check -2 instead. And see, so 6 comes down, the 6 times -2 to -12, plus 13 is 1, times -2 is -2, plus 1 is -1, times -2 is +2, and then adds to 0. Okay, so sweet, found one. And so this resulting polynomial is 6x squared plus x minus 1. We found one of the zeros, which is -2. And to find the remaining ones, we're just going to use the quadratic equation. X equals to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, which is, let's go down actually. Just -1 plus or minus the square root of 1 plus 4 times 6, which is 24. So square root of 25 over 2 times 6 is just 12. And this is going to split into two cases. Square root of 25 is 5, so it's -1. Oh, sorry. -1 plus 5 over 12, or -1 minus 5 over 12. Okay, and then what is that? -1 plus 5 would be 4 twelfths. 4 twelfths is 1/3. Or if it's -1 minus 5 is -6 over 12, which is -1/2. Okay, so as far as question B is concerned, I found my zeros, right? -2 was one of them, and then 1/3, and then -1/2. Now, okay, here's where I wanted to talk to you guys. I know I realize I've been actually saying, I think I might have explained this to you before too the wrong way, but when you factor something, like the natural way to think of a polynomial that has these zeros is to just do the obvious thing, right? And just say, okay, x minus that, minus -2, x minus 1/3, and x minus -1/2. Of course, if you have minus a negative, you can treat that as a positive. So it's x plus 2 times x minus 1/3 times x plus 1/2. Okay, and what you have here is you do have a polynomial with the correct zeros. So you have a polynomial that shares the same zeros as the original polynomial, but that doesn't actually necessarily mean that it is the same exact original polynomial. The only, and really the only difference is there could be some number out to the front that this whole thing is multiplied by, like any number, like it could be 10, could be 6. I think it is actually 6 in this case, but, or something like that, whatever it is. But whatever this number is, this will change the overall polynomial while still maintaining those same initial zeros, right? So coming back to how do you answer the question though, the way to answer this question is actually the best way is to run synthetic division until you find the remaining correct factors. So that's the safest route. Instead of having to worry about, okay, I don't know what the coefficient number is here, that leading term. So instead of I'm just writing it out like that blindly and try to figure it that way, what I'm going to do is take a step back. Okay, I already know. Let me make a note actually. So zeros, let me make a note of the zeros. -2 is 1, -1/2, and +3, right? And +1/3. Okay, so now what I'm going to do is I'm just going to run my synthetic division with this polynomial, and then that's going to give me basically my answer. Watch how this works. So I have, I'm gonna do it with -1/2 because that's the next zero in line, right? And here's my coefficients: 6, 1, -1. 6 comes down, times -1/2 is -3, plus 1 is -2, times -1/2 is +1, adding to 0. And so what I get is 6x minus 2. Okay, so what that means is my actual, from the original polynomial, my actual factored form is going to be x plus 2. That came from dividing by x plus 2 basically, right, synthetically. And then x plus 1/2, that came from dividing by x plus 1/2 synthetically. And then the last term is 6x minus 2. 6x minus 2. Now, if I wanted to, write this this portion more similarly to how I had it before, I can do that. I can actually factor out, I could factor out a 2 right off the bat, right? I could factor out a 2 and then I'd have x plus 2, x plus a half. This would be 3x minus 1, right? Or if I wanted to look even more like how I had before, where this x term is just a regular old x, I could actually have divided this whole thing by 6 instead. And then what you have is x plus 2, x plus a half, and then factor out a 6. This is going to be x minus 2/6. Of course, you can change that to x plus 2, x plus a half, and 6x minus 2/6 is just 1/3, right? So 6x minus 1/3. Okay, and then this looks kind of weird the way it is right now, because the 6 really shouldn't be there. Conventionally, you bring the whole numbers to the front, right? So 6 in the front, x plus 2, x plus half, and then x minus 1/3. All right, so that's one correct form here. That's one correct form. This actually over here is not necessarily wrong, or like something like, if I was, I had it before with the 2 here. That was also not necessarily wrong. Here, actually, I would say this could be simplified because these guys are both divisible by 2. So you should at least take that step to pull out that 2 if I want it fully factored. But yeah, okay. So fully factored, I say this is an acceptable form here. Sorry, I shouldn't be crossing it out. This guy here is an acceptable form. Or, another acceptable form would be, if you didn't want these fractions in there, you could actually borrow the 2 from this 6 and say it's x plus 2. This would be 2x plus 1. And then borrow the 3 from that 6 and then make this 3x minus 1. So this is maybe the prettiest form. Either one of these, I'd say, is a correct factored form. Okay, so that's the question. And, because I've been explaining this part wrong, actually, I'm not going to directly put a question on factoring polynomial completely on the exam. But what I'm probably going to do is add an extra credit question about that. And by the way, you guys, last time too, there's actually more points available than I graded it out of. So it was actually possible to get over 100% on the previous exam. And I'm going to add this extra credit question to the second exam too. So that means you're going to, again, have a possibility of getting over 100%. Okay, so just to kind of like pad your scores slightly. Plus you had the, actually, no, I don't know, I take it back. I was thinking about some other class. Okay, so yeah, let's do the last part of the question, which we haven't done yet. And I erased some of the important parts, sorry. Okay, so we did parts A, B, C. Last is to sketch the function. But the only real thing we need is the roots and then looking at this original equation. So let me just remind us what the zeros were, the roots. They were -2. It was -1/2, +1/3. Shucks, I forget. Which, yeah, that's right. Okay, so first thing, to graph this thing, let's set up our axes and graph the zeros. So here's x, here's y. -1, -2 right here. Boom, 0. 1, 2, I got a -1/2 over here and +1/3 over here somewhere, right? Now all of these are multiplicity 1, so I know that the graph is either going to pass through the points, something like this, and go down, or it's going to pass through the points, something like this, and go up at the end. Now which one is it? Well, just look at the end behavior of original function. It's a positive 6x cubed, right? And really this 6x cubed, this is the only term that really matters towards the end. That's going to overpower the x squared and x term. So as x gets really big, this term is going to be positive, meaning you're going to go up this way, right? And as x gets really negative, this is going to be, x cubed is going to be negative, so it's going to go down that way. And that's consistent with one of the possibilities, right? Going down as I go to the left, through each 0, and then up as I leave. So there's this quick sketch of the graph. All right, and that's it, guys. Yeah, that's it. So sorry about the mistake. Hope that clears things up.